Okay, thank you very much, Andrea. So I'm gonna take what Andrea said in terms of data linkage in maybe a slightly different way from what you were talking about, but I really want to use this as an opportunity to continue the conversation that Mark so nicely started. So before I start, I'd just like to say who I am and who I'm representing. So on my badge, we'll see NCTA. So NCTA is National Cancer Imaging Translational Accelerator. It's a bit of a mouthful, but basically it's a partnership between 9 of the UK's leading advanced imaging institutions funded by NCTA. And what I run is something called the repository unit. It's part of NCTA, and the aim of NCTA is to establish sort of advanced imaging trials and to have a unique ability that builds on a whole load of things. Let me acknowledge the people that I work with, fantastic team who've been working with me for a while. So I want to continue, as I said, the conversation on pseudonymization, and particularly look at the whole question of the context in which research occurs. And this has a practical impact. There are lots of nuances around what we should be de-identifying. I'll talk a bit more about pseudonymization and the DICOM standard, and then just give a few conclusions, and they're not so much recommendations as suggestions of what has worked for us and what worked in our particular context. So I want to start with de-identification of philosophy, and there are two ways you could go about this. You could have a very rigid set of rules that says thou shalt de-identify these things, remove all these things from your data, and then you'll be fine. And then the more nuanced approach, often coming under the heading statistical disclosure control, which actually says, let me take a bit of time to examine what my problem is, what are the real risks involved. And I refer to the US and particularly the HIPAA Healthcare Act because that has two categories that exemplify this exactly. One is called the safe harbor approach, where there's a list of literally these are the things you have to take out of your data and then it'll be fine. And then there's what's called the expert determination way of doing things. And strangely enough, that's not used very often because it's very difficult to Institutions much prefer nice black and white rules that say and you can absolve yourself of responsibility. One question that we should say in the statistical way of doing things is I know that I can never completely remove all risks of re-identification, but how do I get below a sensible threshold of but what is that threshold? What error am I prepared to tolerate? And this plays directly into the context of our pseudonymization. Who needs to see your data? And in terms of what Andrew was saying about what additional data come with it when you decide and you try and persuade your hospital to let you link to your data different bits of information from other parts of the clinical record, who is going to see this, and how important it is it that we check who can see it and what other information these people have available to them, because if we show them some genomic data, if they happen to have some knowledge in the field about the rarity of a particular disease, some of those data may indirectly help us identify the patient, even if our images themselves aren't identifiable. So who can see this is really important. And I want to give you some examples of two sort of rather extreme cases. The one is completely publicly released data. So this is typically something like the Cancer Imaging Archive, or as Mark referred to previously, Kaggle challenges or other challenge data sets. And the whole purpose of challenge data sets is that you let everybody see the data, so you get the maximum number of eyes on these data, so that you can get all sorts of solutions coming from various diverse places. Okay, so let's assume we've replaced all the obvious things like name, address, hospital, and so on. What other indirect identifiers are there? And so our worry is that because we've let anybody see the data, we've assumed these are pseudonymized, these are de-identified, an attacker can access, we assume an attacker can access any other data available on the internet to triangulate a search, right? They can use other previously released data sets. So you have to be mindful of the fact that somebody else might release data that might relate to your data. They can use social media. So if you've released the data for scan or something like that, then in theory they can go and look at somebody's social media post, and these people might have quite innocently said, "Oh, I had to visit the hospital today," or something like that, and the name will be in the social media post, right? So they can use phishing results. Arguably, you can assume that the attacker doesn't have access to hospital records. If your attacker is a state-sponsored person with lots of complicated technology, then you might not be able to assume that's correct. But it's probably worth assuming that the attacker doesn't have access to hospital records, because otherwise they just go and raid the PACS anyway and really look up your person. You can assume that I think that a determined attacker can deploy arbitrary, quite large resources to this to re-identify data, but the resources aren't infinite. So for instance, you can't assume that if you release an image, they can scour and try and image match every other image data set on the internet. Although you can do a Google reverse image lookup, so who knows? Attacks can be automated, right? So the argument why would they bother is not the right one. You could, obviously people have hypothesized situations where you're doing a direct attack against a celebrity or something like that, and it's important. You might want to be interested in extortion, sensationalist publicity, or such things. But really, you can automate all these processes, right? So one has to assume that some malign actor might be out there just with server farms churning, trying to do this. And the point is that they only have to be lucky once and get a big payday, and they might just as well try and re-identify every data set that's out there, because one of these days they might be lucky, right? So all of these things are quite scary. And that's the reason why we try and do a really good job on de-identifying these data sets. This is a key reference to these. Clooney et al. David Clooney's really big in the DICOM world, and they just reported on best practices and recommendations in precisely this area. So most of us might be interested in the opposite, or many of us will be interested in exactly the opposite extreme. We're doing a small, maybe single center phase 1 clinical trial. And what do we care about? The data can be seen. Who can see the data? The trial coordinator team, the sponsor, and the scientists analyzing this. So if it's a really fairly small study, then that team might be small. And what's more, they might be directly involved with the patients. They might be involved in patient recruitment, might even be limited even to the same team that's involved in the direct care of the patient. So I have a lot of discussions around this with people, because they say, well, we can all see PACS anyway, right? We can all see, if we want to, go and look at the data. And the data can all be isolated. So what are the issues? Well, de-identification is obviously still important. The risks are a different nature, right? It's a violation of GCP. You might unwittingly introduce bias into your study if you know which patient is identified with which identifier. As Mark said, and I forgot to put in here, if you're trying to do a blinded trial, then it's not useful if your radiologist already knows who the patient is. But also, on the other hand, radiologists are very good pattern recognizers, so they might even remember that they looked at this patient before, and so it's really hard. The risks are of a different order, but they're still important. And it's really important to know that all of these will eventually involve a loss of patient trust, right, in the whole system, and that's really important for the good conduct of clinical trials. Crucially, we don't expect the motivated attacker, if there's a really malign actor out there, to have access to the data. It's not the same as a public release. So we assume we can trust the clinical trials team. So really, what we're worried about in terms of data security and malign re-identification is routine access control, and it's not so much a worry about the re-identification. Okay, so what I'm most involved in, what my NCTA job is the sort of halfway house between these two. I'm looking at multi-center trials. And what's important here is where are the data coming from and who's sending them, because that crucially determines how well you can do anonymization. So we'll assume that the people who can see the data are pretty much the same group of people as for the single center trial, but the difference here is that the team might be less likely to be involved in direct patient care, certainly for other hospitals where we're getting data from. The analysis team might be a bit larger and involve individuals from several organizations. And crucially, data sharing of curated data might occur between organizations. So if you've got a large multi-center trial team, the analysts might be from multiple organizations as well. And what that means is it's vitally important to map the egress points of data from your system, to be true for sharing data, who can send data where. But what I really want to talk about is the fact that data upload takes place from multiple centers. Even though each center can only see its own data, the problem with this is that you're relying on a lot of different people to get the data into your system. So the staff who are sending it might not be familiar with how DICOM works. They generally have limited time because they're trying to fit this into a busy schedule, and routine work often has higher priority. You have to interact with hospital tax teams and IT departments at different institutions. They might already have their own pre-existing ways of doing the identification, so you don't have control over that necessarily. Sometimes their de-identification is over-restricted and it damages the data so that it's unusable for the trial. Sometimes, although they think they're doing the right thing, it's not actually restricted enough and they leak data. And you don't know what staff training has happened at your local trust. And so the main risk here is accidental disclosure that you think you've de-identified the data, or you put in the contract with the organization that they accurately identified the data, but it doesn't happen correctly. And again, this leads to loss of patient trust ultimately in the trial system. So my context is that we're dealing with a lot of partners. So these are the partners that that ICRMH has relationships with, and NCTA has on the other NCTA repository nodes, as we call them. There are all these other institutions as well. So how does all this influence some of the things that we were talking about in terms of that Mark was talking about? So let's pick dates to start with. So if you're looking at open access data, our key risk to mitigate is this whole business of reverse engineering the data. So in some way we can re-identify the data subject. Assumptions, as I discussed before. Now, if you go to a thing called to Ben Goldacre's review, which is a really good read for anybody who hasn't read it all, there's a section on de-identification on page 90, and it has a really good review of what are the dangers of linkage of data from that an attacker could get hold of. And we talked about this this mitigation method. Mark talked about dithering dates, which basically means adding or subtracting an amount to the dates. So it's almost right, but not quite right. And so there you've got a balance between whether it's effective at mitigating the problem and whether the data is still useful. And yes, I say below, the most serious problems here occur when the images are part of wider data release. And I'd be really interested afterwards over coffee to discuss this. It's a very interesting problem. In the clinical trial, my assessment, and this is only me, so it's personal opinion, right? I think the key risk to mitigate is accidental corruption of the trial integrity by incorrect selection of an imaging session. Because you get these patients on these trials and they have lots of imaging sessions at different times. How do you get the right one? And the risks of dithering, and which any computer scientist or any scientist will say, what you're doing is deliberately corrupting your input data. That's not a good idea for science. So you have additional records. The hospitals have to keep records of what their added or subtracted value for the date was, and they have to not get that wrong. And as the sponsor, you don't have any control over that. The hospitals might not have the infrastructure to do that anyway. So how do you then match what you've delivered in your images to what's been entered for all the other time points in the non-imaging data? So this refers directly to the linking of data that Andrea was talking about there. What happens if your site, for some reason, has an error in their internal processes and they don't do the dithering right, or they fail to do it at all? What happens if your trial protocol depends on multiple scan sessions at multiple dates, and you've dithered them so that they end up the wrong way round? That could be really problematic. And what happens if staff change and the whole procedure can be very difficult? So there are completely different decisions to be made there, I think. UIDs, what's the corresponding risk? And that depends on what other data the attacker might have. So some people might say, well, one UID per patient, that must mean that that's a unique identifier, not just for the individual DICOM file, but for the patient, or bits of the UID are unique to the patient. But to realistically use that, you have to have a link back to the PACS. And again, if you have a link back to the PACS, then, well, you could get the patient data anyway. So I don't think that's credible. But there are things that are embedded in the UIDs in terms of the way the UIDs are constructed that mean that you could reverse engineer the data. And interestingly, the UIDs are constructed so that in the UK, at least, a hospital is assigned what's called a route. So the first bit of the UID is actually based on their BACT registration code. It's pretty bizarre. So you can reverse engineer a UID to find out which hospital did wipe the data, and other components might identify the date, time, or whatever. So again, the normal response to this is, well, there's all this potential worry. We're not sure whether we need to do it or not, but we might as well do this replacement just in case. Okay. So why is that a problem in a clinical trial? Well, again, the key risk to mitigate is accidental corruption of data integrity. And the reason for that is that all these things are designed to link to, the UIDs are specifically designed to link together bits of a diverse record that contains multiple images. And if you don't replace them all as a body, all in sync, then you can break that internal linkage. So, for example, and I won't talk very much about this, but that linkage is important for image registration between different modalities. It's important for making sure that regions of interest overlay on the right scans. So these are really vital things in analysis of data. And again, these ones at the bottom are two things that you might not think about. So if you accidentally pass your images through the anonymization twice, and you're using this hash-based technique that Mark described, then what happens, most of the anonymization, just second time you go through it, doesn't do anything, right? It just leaves all the fields the same. But if you anonymize by hashing UID twice, then you end up with something completely separate, that then anything that has run through the routine twice won't match anything that's run through the routine once, and you've just got a nightmare of confusion. So that's a really technical but credible thing to happen. It does happen. And then the last thing is something that you might not think about, but you do this, the unique identifier is designed so that it uniquely identifies this particular identifier, right? So suppose you're entering something into a Kaggle challenge and you change the identifiers, you send it in. Now, a little bit later on, you're taking part in another study, and somebody else does the identification of the different bit of software that changes the UID of that image to something different. Now, somebody who is looking to try and assemble, super data sets of everything will take these two different data sources from the challenge and from somewhere else. We'll take these images, say UIDs are different, these are different data, and put them together as two different data sets. And now your training data set in some future trial is corrupted because you've got duplicate data. So this can all cause bias. Right, I'm going to skip through. I'm sorry, I'm well aware. I'm
time.
I'm a bit over time. That's a really bad example.
This game.
Thanks to my previous speakers. Okay, so key steps for de-identification. Then Mark's touched on these, but I want to emphasize that few really important. The first that is note there are 3 separate operations that you have to do, and all of these need to be done at the site itself because you shouldn't send data out to your hospital that's identified. So the first thing is filtering the data, and it's a little known fact that if you go to a PACS and you say, I want CT scans, you download what you think is a CT session, if you like, and you'll get other stuff as well. And it might be a radiology report or something else. I'll show you some more examples of that in a minute. Second thing is finishing pixel data. Mark's already talked about very nicely, removing version annotations. And one thing that you might also have to do, not just annotations, but if you're doing head and neck cancer, for example, or you need the head, if you're doing brain scans, a 3D render of a 3D data set can be matched against a photograph from somebody's LinkedIn page or their social media or whatever. So it's really easy to identify. And cleaning the metadata is what we've been talking about most of the time. And that's often what people talk about when they talk about pseudonymizing images. But really, it's all 3 things we have to worry about. So what can go wrong when studies are sent between institutions? This is my nightmare. But it's not a new nightmare. It's something that is an age-old problem. So in previous eras where you were sending plain film X-rays around or whatever, you could quite easily find that you picked up a stack of X-rays and somewhere in the middle has been interleaved a sort of document that, like a report or something that just happened to have stuck to the to something. So this is what you get. This is what the study team finds, and this is exactly the problem with sites failing to filter the data that come out. In principle, we could do this on arrival. But if we do that, then it's still dangerous that the study team, the site team has sent something bad out, and we need to identify that and stop it. So all of these are things that we have found in data that a site, sites have sent us. We found radiology reports. We found these CT dose reports are a complete pain in the neck. They get sent quite often. And other reports with lots of information, as well as the standard screenshots that have patient information, but burnt in sort of not the same place in every image, so it's quite difficult to de-identify. Why does that happen? Why do people send these things when we tell them explicitly not to? Well, it's due to a lot of things, but a combination of lack of experience, poor knowledge of what you can get in the DICOM scan, lack of training, not enough recent training, simply thinking that they know what they're doing anyway, But the large thing is really insufficient time in the clinical setting. We're trying to do these things really quickly. And it's also poor user interface design on the thing that exports the data out of PACS. So this is our sector PACS exporting out of the sector PACS. And it's really easy just to tick a box and say, right, export this scan. So to the trained eye, this already has a little bit of worry attached to it. So see this little thing, IEP, that's a red flag to me because it tells me that the data has come into my hospital from outside. We're a tertiary centre. So we know what our own data looks like, and we can be fairly relaxed that we know what's in our own data sets. What comes in from the outside, it's like the Wild West. You just don't know what you're expecting. Even if you drill down to see what series are in there, so you look on PACS and see this, and you have to be looking very carefully to know that the scan that you want is this. It says CT, abdomen, pelvis, contrast enhanced, whatever. If you don't notice that there were only 2 images and think something weird about that, then you might get that wrong. It's only by actually drilling all the way down and looking at the thumbnails that you can spot which is the one you have to filter out. Cleaning the pixel data, lots of issues with that, and I won't go through them all, but it's really not easy. I'd love to implement the thing that Mark said, which is basically you use something to optically recognize the characters, and then you compare that against the known list of things that you need to remove. Check you've done that. Our problem is that in our multi-center context, we don't have that because they've very kindly stripped out all the things we want to remove. So what we need to have a project on is actually a machine learning project that really says, ab initio, without knowing what the things you might need to remove are, go through it and think, can my machine recognize what's safe and what isn't? That's what we should. Cleaning the metadata, lots can go wrong. This is a classic one. The centers have cleaned the metadata and they've removed all utility from the data. We just get a bunch of scans that say unknown. Equally, you can under-anonymize the data and leak both the direct and the indirect identifiers. So we have sites that claim to have de-identified data according to their institutional methods, still has the accession number, it still has the patient name in clear in private tags, all sorts of things. So finally, then very quickly, last 2 slides. How do I think we should be doing de-identification? The DICOM standard itself has really good instructions on how to do this. So the standard itself is extremely extensive. It's not even for experts to know where these metadata, where these identifiable data could be lurking. They have several new revisions each year, so there are lots of unknowns here. So this article, Clooney et al. That I talked about earlier, said various authors have published their own lists of what you should remove or what to obtain. We are not convinced that any of these are sufficient or safe. Instead, we strongly recommend the use of the list specified in the DICOM standard. And this is the essential reading. DICOM standard part 15 section E. It's essential reading people like me. I don't expect to look at this, but basically there's a humongous long table of all the things that you should remove and what to do with them. The basic profile is very conservative. It just basically removes anything that could possibly be harmful, but it has a bunch of what called retain options that allow you to do it. That translates it into an anonymization script. This is the XNAT way of doing things. This is the CTP way of doing things that Mark talked about earlier. So finally, this is my last slide. So these are my suggestions based on our context and our experience. So we still don't know what our threshold should be, but basically we've got a rules-based system. but it has different options in place corresponding to different risk levels of data. So where we send the data, who it's for. And so we have an XNAT-based repository. So there's a really good tool called the XNAT Desktop Client for doing the anonymization and upload. We try to filter incoming data as well as assuming that that will filter outgoing data. We try to filter the data as they come in so that we don't let things in that we don't want. We train staff at sites. We have an extensive program of training at sites so that they should inspect the images and deal with them. We use an anonymization script that is not left to the centers to administer. We administer the anonymization script. Then it basically, XNAT Desktop Client sucks it from our server, which is secure, to their end. The anonymization occurs at their end, but with our script. And we still, after all of this, we still try and ensure that incoming data are audited with human eyes on the system. You can't just assume that the data you're getting in are going to be fine.